on part D, this one I actually think, well, it's up to you. I think it's not so hard to spot some inner outer function stuff going on there. What's tricky about this is we actually have kind of a double composition going on. So immediately what jumps out to me is that I see this cosine function stuck inside of a square root, so that's definitely composition. And if I'm going to claim that the cosine is my inner function, I see that outer function sine of the same stuff floating around. So I like that as a candidate. What's slightly tricky here is that that cosine function is actually composed with a 2x minus 1 as well. So I would say you are allowed to do substitution twice. So we could start with, here, let's just do it. We could start with, let's substitute out the 2x minus 1 because that's definitely an inner function. I don't see its derivative floating around. The derivative of 2x minus 1 is 2, but that's not really a big deal. As we've seen, if it's just a constant, it's really easy to fix. So the derivative of my w with respect to x is 2, which means if I move the dx up and divide by the 2, I can replace my dx's with dw's divided by 2. So that turns this into sine w multiplied by the square root of cosine w multiplied by dw over 2. I'm going to just sneak that 1/2 out in front right away. So this is substitution number 1. I'm going to give you another option as well. We would then have to follow that with, okay, now I have the cosine under the square root, which means that potentially my inner function could be cosine w, my outer function could be the square root of that function. And I need to pick a new variable. I can't use w. So let's say I want to replace everything with z's. So I'm going to say z is going to replace my cosine w. dz dw is going to be the derivative of cosine, which is minus sine w. If I start messing around with this, I could say, all right, so sine w and dw could get replaced by my dz as long as I throw an extra minus in the mix somewhere. Which then turns this into the 1/2 is still sitting there. Sine w dw becomes my minus dz. So here, we're going to save that up for just a second. We're going to have square root of z, that's the square root of cosine, and then sine w dw gets replaced by dz, and then I'm just going to throw that minus out in front as well. I encourage you to move those constants out whenever possible to make things simpler. So here I'm thinking z to the 1/2. Since I've gotten rid of all w's, I can go ahead and integrate. So I'm going to have a negative 1/2 just sitting out in front. I'm going to bump my power up to 3/2, and then 3/2. I need to divide by 3/2, which is the same as multiplying by 2/3. Don't forget your plus c, I almost did. Okay, and then we can cancel a 2. So I have a negative 1/3 z to the 3/2 plus c. And I want to be done, but I was integrating a function of x, and I ended up with a function of z. So I'm not. So I'm going to say, okay, well, z's can get replaced by cosine of w's. And I'm still not done, because I have to replace the w's. Here, I'm going to get rid of parentheses. I'm going to put that 3/2 right on the cosine, means the same thing. So w gets replaced with 2x minus 1. And now I am finally done. Okay, so option number 1, absolutely nothing wrong with it. But I will say that I encourage you as we work on these to get comfortable not using a substitution for the really simple things that just chain out a 2. So the way that would look is I would just do a single step. I would say I'm going to replace the whole thing in one step, cosine 2x minus 1. Which means my dw dx is going to be minus sine of 2x minus 1, and then I'm going to chain out an extra 2. So when I go to replace, I can replace the sine 2x minus 1 dx with a dw over negative 2. Okay, so when I compare back to my original, I'm going to say that equals the sine 2x minus 1 and the dx get replaced by the dw, but I need to make sure that negative 1/2 shows up. I'm going to move it out in front. You don't have to. You can leave it in there for now. And then the cosine, the square root of the cosine is what's left over. I've replaced the cosine with a w, so this jumps me straight to the square root of w. So this is definitely going to be less writing stuff down, but there's a little bit of work that has to happen in your head along the way. In fact, not even that much. So I really encourage you to not get too worried about having simple inner functions like 2x minus 1 or 7x, anything linear. It's not going to be that big of a deal. So here, I'd say antiderivative of w to the 1/2 will give me a w to the 3/2 that I multiply by a 2/3. And that means I have negative 1/3 w to the 3/2, which is looking very familiar. And I can go straight back to x's since I only did a single substitution and say w is a cosine. Hold on, I got junk in my way. Okay, cosine to the 3/2, 2x minus 1. Oh, and don't forget your plus c. That should have been showing up on all of those. Okay, so either way is fine. I encourage you to do it the second way if you're comfortable, just because it saves a lot of scribblings and giving yourself chances to make little mistakes.